Now let's see group 1A, that is alkali metals, and 7A, that is halogen group. To begin with it, let's see some of the elements involved in 1A. 1A group consists of lithium, sodium, potassium, rubidium, cesium and francium. This element, all of them are univalent, that is having valency 1, highly reactive, highly electropositive, very soft metal, easily can be cut with a knife. Conductivity we talk about, it's highly conductive, very good conductor, whereas they are very strong reducing agent and has a very low electro negativity. With respect to reaction with non-metals, they are highly reactive and always forms electrovalent compound, that is forming an ionic bond. Whereas with respect to hydrogen, it reacts to give you hydrides, which are again ionic in nature. Now with respect to 7A group, which are halogens, which includes fluorine, chlorine, bromine, iodine and astatine. Astatine is a radioactive element. They also are univalent. They are highly reactive, but this time they are highly electronegative, and they are non-metals. They are a bad conductor of electricity. They are a very strong oxidizing agent, highly electronegative in character. They always form a covalent bond. With hydrogen, they form covalent hydrides. Now let us consider the properties which are repeated after a small interval of time, which we say periodic properties. To begin with it, the property which is repeated involves first the atomic radii. Now what is atomic radii? It is the distance from the center of the nucleus to the outermost shell of an atom. The second property is that is ionization potential. What is ionization potential? It is the minimum amount of energy required to remove the most loosely bonded electron from the outermost shell of an isolated gaseous atom. Then the third property is electron affinity. It is the amount of energy released or given out when an electron gets added to the outermost shell of an isolated gaseous atom. In case of electronegativity, it is the tendency of an atom to attract electron towards itself, whereas non-metallic character is the tendency to accept electron, and metallic character is the tendency to donate electrons, which are also called reducing agents. Whereas non-metal which accepts electron, they are called oxidizing agents. Now let us take the first periodic property, that is atomic size. We already know what is atomic size. It is the distance from the center of the nucleus to the outermost shell. Now let's see which are the factors which affects the atomic size. There are two major factors which affects the atomic size, and they are number of shells, that is the orbits, and the nuclear charge. Now as we go across the period, we notice the number of shells remain same. but the nuclear charge goes on increasing. As a result, the electrons are pulled towards the nucleus. So the size goes on decreasing as we go across the period. Whereas if we consider down the group, the number of shells increases, whereas the nuclear charge also increases. According to the increase in number of shells, the size, that is atomic size, should increase, and it increases also. Whereas if the nuclear charge increases, the size should decrease, but it is not decreasing as we go down the group. Reason for that, the nuclear charge increases, but at the same time the number of shells also increases. So the size will go on increasing down the group. Across it will decrease. Now let's take the second periodic property, and that is ionization potential or ionization energy. It is the amount of energy required to remove the most loosely bonded electron from the outermost shell of an isolated gaseous atom. There are two factors which affects it, and they are: first, atomic size; second, nuclear charge. We have already discussed, as we go across the period, the size goes on decreasing. So it becomes very difficult for us to remove the electron from the outermost shell. So the IP, that is ionization potential, will go on increasing as we go across the period. Whereas the nuclear charge also increases across the period. So in both the cases, the IP will go on increasing across the period. But as we go down the group, the atomic radii goes on increasing. So it becomes very easy for us to remove the electron from the outermost shell of an isolated gaseous atom. Reason, the electrons are far away from the nucleus. So the IP will go on decreasing. But at the same time, the nuclear charge increases. So according to rule, the nuclear charge increases, IP should decrease. But the number of shells increases. That's the reason the IP will go on decreasing down the group. Okay, now let's take the third property. And the property is electron affinity is the amount of energy released when an electron gets added to the outermost shell of an isolated gaseous atom. It is affected by the same factors which was affecting ionization potential, and the two factors were atomic size and nuclear charge. We all know as we go across the period, the atomic size goes on decreasing. So the electron affinity will go on increasing. Even the nuclear charge goes on increasing across the period. Whereas down the group, the number of shells goes on increasing. So the size will go on increasing. So the electron affinity will go on decreasing. The nuclear charge down the group increases, but this is compensated by the number of shells which are increasing. So the electron affinity will go on decreasing down the group. The next property which we are going to take is electro negativity. What is electronegativity? It is the tendency of an atom to attract the electron towards itself. It is affected by two factors, and the two factors are: first, atomic size; second, nuclear charge. Now we all know as we go across the period, the size goes on decreasing. As a result, the tendency of an atom to attract the electron increases. So the electronegativity will increase as we go across the period. Whereas down the group, the number of shells goes on increasing. Even though the nuclear charge increases, it is compensated by the increase in the number of shells. So once the number of shells increases, then the tendency to grab the electron decreases, whereas the tendency to give electron increases. So as we go down the group, the electronegativity will go on decreasing. Now let us consider the metallic and non-metallic property of the elements. Now, what is metallic property? Is the tendency to donate electron, whereas non-metallic property is the tendency to accept electron. Again, it depends on only two factors, and they are atomic size and ionization potential. If the size is larger, then the tendency of an atom to donate electron will be more rather than taking electron. At the same time, if the IP, that is ionization potential, is less, then the tendency to remove electron will be more, that is to give electron will be more compared to accepting electron. Now, as we go across the period, the IP goes on increasing and the size goes on decreasing. So what will happen to the metallic character? It will decrease from left to right, whereas non-metallic character will increase as we go from left to right. But as we go down the group, the size goes on increasing and the IP goes on decreasing. So what should be the tendency? Right, the tendency will be to give electron rather than accepting electron. So the metallic character will increase as we go down the group, whereas non-metallic character will decrease down the group. Now let us take some more properties, general properties like density, melting point, boiling point, and we'll talk about the stability of an element. Now, as we go across the period, the density and melting point increases gradually to a maximum across a period, whereas down the group, again the density of an element will increase, whereas melting point and boiling point will decrease. In case of certain chemical properties like oxide formation, across the period it becomes strongly basic on the left hand side, but as we move towards the right it becomes strongly acidic. Whereas if we go down the group, initially it is acidic, as we move downwards it becomes basic oxides. With respect to hydroxide, as we go across, in the beginning on the left hand side it is strongly basic. Again, as we move away from left hand side moving towards right hand side, it becomes more amphoteric, whereas down the group it is less basic in the beginning and strongly basic as we go down the group. With respect to oxyacid, as we go across the period, that is from left to right, it becomes weak oxyacid, but as we move towards the right it becomes strong oxyacid. Whereas if we go down the group, initially it is strong oxyacid, as we move downwards it becomes weak oxyacid. Whereas with respect to hydride, on the left hand side it is strongly basic hydride, whereas as we move rightwards it becomes strongly acidic hydride. Whereas in case of down the group, it becomes less acidic in the beginning, as we move downwards it becomes strongly acidic. We find out the stability by taking the neutron to proton ratio. If the neutron to proton ratio, that is n by p, the answer if it comes out to be 1, then it is highly stable. For example, like we take sodium, potassium and lighter element, more or less the number comes to 1. And for heavy metals, the n by p ratio goes above 1.5, so it becomes a radioactive element which starts emitting radiation, which is very dangerous. Now since we have already covered up with the concept part of it, let's see some of the application oriented questions. To begin with it, they might ask you, name an element of group 1A, an alkali metal, which is always kept under kerosene. The answer for that will be sodium metal, which is very soft and dangerous. So it is always kept under kerosene.